So today we're going to talk about angles formed by tangents and secants. Now we already talked about inscribed angles and angles formed by two chords. So let's review those two and we'll discuss angles formed by secants and tangent. So here, what we're going to do is we're going to write the relationship between the variables a, b, c, or d. So each of the diagrams are actually labeled with a, b, or c, or d. So if you look at the inscribed angle, here the inscribed angle is labeled as a degrees and the intercepting arc is b. So if we write the relationship between a and b, it would be a. In this case, it would be a would be half of b. So it would be divided by 2. Okay. So let's take a look at the chords here. So a here, angle, is the angle that is formed by the two chords. So these intercepted arcs are angle arc B and arc C, or measure B, measure C. So to figure out angle A, so A would equal sum of B plus C and then divide by 2. So there's the 2 that we talked about prior. So here's some of the new stuff. Now, if you take a look, we have a tangent here, and we also have a secant. And this actually angle forms on the circle. So this is very similar to the inscribed angle. So this angle A is actually half of this arc. So it's very similar to the inscribed angle. This actually has the same property. So here, angle A is going to equal B divided by 2, just like the inscribed angle. Now in the inscribed angle, it actually looks like two secants, but the angle is formed on the circle. This is also formed on the circle, but it's actually a tangent and a secant. So it may look different, but it's still half of the intercepted arc. So let's look at the other 3 that's left over. So notice all of these 3 that we're going to look at, all these angles form outside the circle. So that's important. Now we've talked about angles that form on the circle, which these 2, and this one is inside the circle, but all of these form outside the circle. So let's take a look. So this one is a tangent and a secant. And the angle over here that is formed outside is A. And these 2 actually are the 2 intercepted arcs. So you have to recognize the intercepted arc. So if you notice this measure over here and this measure here is the intercepted arc. Notice there's another arc here that's actually part of a whole circle, but this part we don't really need. We only need these 2 intercepted arcs that are formed by the secant and the tangent. So to figure out this angle, A, we find the angle A by subtracting the 2 intercepted arcs. So C is bigger than B, so we're going to subtract the small one from the larger arc and then divide by 2. And that's how we find the angle that is formed by a secant and a tangent. Okay? So remember, when we have the 2 chords that form inside, we actually add and divide by 2. In this case, we subtract and divide by 2. The next one. So this also forms outside the circle. And if you notice, they have 2 angles that are intercepted. So angle B here and arc B, arc C, those are intercepted. So these 2, you're going to take the difference of the 2 and divide by 2 to find A, just like the previous one. So A here is going to be arc C, so it's the bigger arc minus the smaller arc in this case, divide by 2, and that's how you find the angle. So if you notice, these are 2 secants. Now there are arcs part of the circle here, but you don't need them. You only need those 2 intercepted arcs. Later on, you're going to see other application problems where you're going to have to figure out the arcs of all of them, but you'll see it later. So the last one, two tangents. Now, if you take a look at the two tangents, it only has two arcs, just like if you look at the previous one, it's actually divided by multiple arcs. So this had one arc, two arc, three arcs here. So a tangent and a secant forms three arcs. If you have two secants, you actually have four arcs. You have two arcs that are interceptive and then two other arcs that are not interceptive. So there's four arcs here. Now when you have two tangent, you only have two arcs. So if you notice, because these are tangent points, you only have one, and then you have the other, use a different highlighter, and notice those two arcs add up to 360. So that's interesting because the two tangents makes two arcs that add up to 360. Now you're going to do the same thing to figure out angle A. You're going to take the difference. So you're going to find the bigger arc, which is C. So C minus arc B divided by 2, and that's how you figure out angle A.